Now let us look at the one of the parametric curve. Sketch and identify the curve defined by the parametric equation x equals to t squared minus 2t, y equals to 3 plus 1, and this is the solution. Okay, so first of all, how are we going to sketch this graph? Okay, so you can make a table. The first one is the t, then the second one will be the x, and the third column will be the y. Okay, so when you can choose, okay, so from this graph actually is from -2. So when we start from t -2, you substitute inside here. So x equals to -2 square minus 2 -2. So we're going to have a 4 plus 4 actually is 8. So this is 8. So when you want to know the y value, so you substitute -2, y equals to -2 plus 1, so equals to -1. So you have a -1. Okay, so the first point will be 8. Okay, this is 8, -1. Okay, so actually this point is -8. Sorry, is an 8, -1. Okay, so the next one, let's say is -1, so -1. Okay, so you doing the same thing. X equals x equals to -1 square minus 2 -1, so it will be 1 plus 2, so this one is 3, so you substitute here 3, and so then you substitute -1 plus 1 actually is 0, so this is 0. So you're going to have the next one is 3 0. Okay, and then you do the rest of it. Okay, so if you can see that is when from the time increasing -2 -1 and so on. Okay, and then you see the curve is going this way. Okay, so you see the arrow, so this one is called orientation, the orientation of this parametric curve. Okay, so what is this orientation? A particle whose position is given by the parametric equation move along the curve in the direction of the arrow as t increases. Okay, so this is the you see the curve increases in this way. Okay, if you see here, okay, actually this one is a parabola. Okay, okay, next. So notice that the consecutive points marked on the curve appear as a t equal t interval, but not as an equal distance. Okay, and this is because the particles slow down and then speed up as time increases. Okay, so from here you can tell that is, it can be okay. So it speed up, then suddenly when they want to do the corner times, okay, it will be slow down. Just like when you do the when you drive along the corner, okay, you cannot be speeding up. Okay, if speeding up, there is a chances that you will going to be having a crash. Okay, so we're going to this way. Okay, then after that, it appears that the curve traced out by the particle may be a parabola. Okay, we can confirm this by eliminating the parametric tree as this one. Okay, this one definitely you're going to learn after this. Okay, so then from here that you can see that actually this is a parabola. Okay, then what is the advantages of parametric curve? The parametric curve have an advantage. They tell us when the particle was at a point. Okay, they also indicate the direction of the motion. Okay, so in general the curve with parametric equation is this way and has an inertial point. So inertial point, so when you substitute a, and then the terminal point when you substitute with the b. Okay, so let us look at the second one. Sketch the parametric curve of this one. Okay, so describe the orientation of the curve. Okay, so now as we do just now, this is the t, this is an x, this is the y, and over here they already given you the range, the domain of the t is from -2 until 3. Okay, generally we just take the integer. If you want to have a very precise graph that you can do by -2, then the increment will be -0.1, increment with the 0.1, or if you want more precise, you can use 0.01 and so on. So generally we have a rough graph roughly sketch the graph. So we just choose the increment by 1, -2, -1, 0, 1, 2, 3. So what you do, you use the -2 substitute into here, okay, for x, so you will get the 0. And if you substitute -2 into the y, you will get the -1. So 4 for this order answer. Okay, so and after that, with this, okay, with this table, the value, then you plot each of it, okay. So please plot according, don't jump up, okay. So because you want to know the orientation, how they move, so you need to plot increasingly, okay. 0, 1. So first thing you need to plot 0, 1, -3, -4, 0, -3, and so on, okay. So over here you plot it in this way. So from this way, then you will know that how it's going to move, okay. So the arrow sign is indicating how it's moving up, okay. So this point, so the arrow on the curve indicating its orientation as t increases from -2 to 3. So when a particle moves on this curve, it will start at 0, 1 and then move along, and then it will be ended at the last one, okay. So this one is called inertial point. This one is called terminal point. Okay. So now is the time that you learn how you want to change from a parametric equation into a Cartesian equation, or we can call it as an eliminating the parameter. Okay, the process of finding the rectangular, okay, as I said just now, either we can use as a rectangular equation, or we can call it as a Cartesian equation. This process of finding from a parametric equation to Cartesian, we call it as an eliminating the parameter, or we actually, another way, we use the substitution. Okay, so you will be given a parametric equations, then you take one of the equation and solve for t. Then you substitute the value of this t into the second equation. Then you will obtain a rectangular equation. Okay, so what we have to do is, let's say we have one pair. Okay, we have one pair like this one. X equals to t squared minus 4, y equals to t. Okay, if we look at both equations, okay, this one is easier to solve for t, okay. Why this one? Because later on you were going to have a square root of x, so something that we try to avoid. So we choose y equals to 2t. So let y equals to 2t. So you solve for t, so your t equals to y over 2. Okay, so you take this y t equals to y over 2, substitute into another one. The first one, because you already chosen this one, so you choose another one, will be x equals to t squared minus 4. So we substitute y over 2 square into here, and then we simplify this one. Depends on whether sometimes you know to be simplified, because this one actually is a parabola. Okay, so a parabola that actually you will learn it in the max 2. Okay, then after that, over here, there is one part of it. They ask you to calculate the respective domain and the range for the rectangular equation. Okay, it's very simple that to find the domain and the range of this equation because we know that the value of x is our domain, the value of y is actually our range. So what you need to do is you substitute -3 and 3 inside the x, you will get the domain. If you substitute -3 and 3 into the y, you will get the range. So now what we do is we try to substitute t equals to -3, then we will get x equals to 5. And coincidentally, because t squared, regardless negative or positive, you will get the same value of x equals to 5. But from what we know that as a parabola, okay, so it will be, that's why there will be a minimum point or maximum point, cut them into two, there will be symmetrical value. So that means they have a value here. So normally there will be like the half of this thing actually is 0. So I try another one, actually is t equals to 0. Inside here I will get -4. Okay, and -4 is less than our 5. So our domain is from the -4 until 5. Okay. After that, how you find the range? So since our range is y equals t equals to y. Is y equals to 2t. There's no square, so it's easily you can find the range by substituting t equals to -3 and t equals to 3 into the y equals to 2t. So y equals to -6 and y equals to 6, and you put it in the range. So range of the function will be -3 until the 6. Okay. Now we look at the another one example. Okay, this one, okay, because both is also not a nice value like previous example, so we can start from our x. We can solve our x for the t. Okay, so we interchange the position. So I have a third t plus 1 equals to 1 over x. And then my third, bring it to this side, will be power of 2. Okay, so I have 1 over x squared. Then this plus 1 will become -1. So what I need to do, I substitute 1 over x squared minus 1 into my y. Okay, into my y. Whenever you see t, you substitute with the 1 over x squared minus 1. Okay, so although it looked very complicated, but you solve for the same denominator. Okay, when you solve for the same denominator, actually the answer is 1 over x squared. This is also a parabola. Okay, so how to find the domain? Okay, this one have no problems of an x squared. So what you need to do, you just substitute 1 and 5 into the x. So you will get x equals to 1 over sec 2, x 1 over sec 6. So you put inside. I think this one, I think is already vice versa. Okay, because it's 1 over. Okay, later on you can check this one by pressing into the calculator which one is coming first. Okay, and then for the range from our y, okay, sorry, I think this one is wrong. Okay, so my y should be t over t plus 1. So what you need to do, just substitute y equals to 1 over, so substitute 1 plus 1, so it's 1 over 2. This one is correct. Okay, it's only just this one is wrong. And then after that, you substitute 5 into it, so you have a 5 over 6. So you put it into the range. Okay, so finish. Okay, now, okay, now we have another version. Is when you want to change parametric equation into the Cartesian, and it involves trigonometry function. Okay, then normally in the trigonometry function, we always will be encounter with our friend sine square plus cos square equals to 1. This is one of the way that you can easily to eliminate the t or the theta, because sine square plus cos square equals to 1. The rest of it is quite difficult unless you have a tangent or the secant and so on. Okay, so example is convert the following set of parametric: x equals to 3 sine theta, y equals to 4 cos theta. How you want to do it? You solve, because we have the sine squared plus cos squared equals to 1. So both of the parametric, we solve for the sine theta, we solve for the cos theta, and we substitute these two into this property. This is this identity. So you solve it, then you already settle. This one you no need to solve it. You no need to simplify. Actually, this one is a circle, or it. Okay, this one is a. I think this one. This is not a circle. This is an ellipse. Okay, okay. No need to worry. Either is a ellipse, circle, and so on. You will learn it in your max 2. Okay, so now this is another example. Okay, a bit more complicated from just now. Just now is a 3 sine theta, 4 cos theta. Now it's a bit more complicated. It's only 4 plus 2 cos theta, -3 plus 3 sine theta. What you need to do is also the same thing. We solve for the cos theta and the sine theta. How you want to solve for the cos theta? Move other thing to the other side. So you have, after that, what you need to do, just substitute into the same identity, sine squared plus cos squared equals to 1. So you put inside, as I said just now, you no need to expand it, just keep it as it is.